Dear students of Vocational Training Diploma on Electrical and Hybrid Vehicles, I am Engineer Mohammed Masad from the University of Jordan, member of EcoCar Committee under the Erasmus Plus project coordinated by the University of Jordan. Still, we are in cluster number 5 about basic of electricity and electronics. Hello and welcome in lecture number 1 of topic number 2 of cluster number 5, which is about basic of electric and electronic components. Dear student, the duration of this lecture will be about 40 minutes and will cover the following chapters. The contents of topic number 2, chapter 1 about an introduction to components, chapter 2 passive electronic components, chapter 3 about active electronic components. Now, go to this chapter about the components. This chapter will give an introduction about the concepts, types, functions, and operation of an electrical and electronic components, such as passive and active components. This chapter will give an introduction about the faults and maintenance methods of different automotive circuits. Contents of this chapter: Introduction to electrical and electronic components, electronic basic components diagrams, difference between active and passive components. Definition of electronic components. Electrical and electronic components, such as elements or devices, are basic fundamental building blocks of an electrical and electronic system, precisely used to affect electrons and their associated fields. These components are often called active and passive elements and may have one or more basic properties, and it behaves accordingly. Electronic basic components diagrams. As you see in this figure, we have many different kinds of components. See here, this is a resistor, this is a capacitor, diode, switches, battery, bridge rectifier, inductor, light emitting diode, LED, transistor, fuse, loudspeaker, relay switch, or sometimes we can call it in vehicles cutout. This is integrated circuits. This is transformer, microphone, antenna. So this is components. Some of them we can call it passive and other called active components. What is the difference between active and passive components? Passive components, they utilize power from the circuit for operation. They store energy in the form of current or voltage. They cannot control the flow of current. They do not require external power supply to operate. So it has its power supply. Active components, they require external power supply to operate. You see the difference between this point and this point. They'll deliver power into the circuit in the form of voltage or current. But here, they store energy. They are control the flow of current. These passive components, they cannot control the flow of current. Active components produce energy in the form of voltage or current. Passive electronic components. Passive electronic components are an electrical component that does not generate power, but instead dissipates power, stores power, and or releases it. In most circuits, they are connected to active components or active elements, typically such as semiconductor devices like diodes, transistors, digital logic chips, and integrated circuits. Passive components. Passive components can be classified into four types. First of these components called resistors. Second part is called inductors or coils. Third one is called transformers. The fourth one is called capacitors. Now, division of the electrical resistance. Resistance is a measure of the opposition to current flow in an electrical circuit. As we see in this picture, we have a light bulb with internal resistance here. It is called electrical resistance. Okay, so this electrical resistance uh, is measured in units of ohms. It's symbolized by the Greek letter omega, ohm. Also, the resistor's ability is to reduce the current, which is called resistance, like this one. A measure of this limit on charge flow is called resistance. So the resistance is to resist the flow of charge. It comes in variety of resistance values, how much there is. Now, resistor is an resistor. What is the definition of the resistor? Last slide, we are talking about the resistance. What is the definition of the resistor? Resistor is an electrical component that reduces the electric current. Its two terminal electrical components in a circuit as shown in the figure, like this figure. This is an electronic component or electrical component, which is called a resistor. This is the symbol of a resistor, okay, like this one or this one. So this resistor will resist the flow of current, and this we are using this resistor to protect a circuit against overload. So the symbol is this, is we call it R. Resistance values is called ohm. Resistance in the circuit consumes energy in the form of heat, like the heating electrical system. It is the resistance inside this equipment is consumes energy in the form of heat. Types of resistor. As you see here, many kinds of resistors here. It's called carbon or metal film. This is a wire wound resistor, and this is adjustable or variable resistor. So types of resistors here, there are many, three types of resistors. Fixed resistor, as you see, this is a fixed resistors. Okay, carbon resistors, wire wound resistors, like these. Variable resistor, or sometimes called potentiometer, like this. It has three terminals, as you hear, three terminals, three terminals, okay, three terminals. Now, according to the power of the resistors, there is different types of resistors according to the power. The resistor power rating is rated in watt, which are units of power. It is called or can be termed as wattage. Yeah. Generally, larger the size of resistor means more power it can handle, like this figure, as you see here. More size, more watt. From this watt resistor to this one, to the half, to 1, to 5 watt, as you see here. 5 watt with 22 ohms. So more size, more wattage. At the wattage of the resistor increases cost. So more size, more wattage, more cost. Resistors generally start from this range of watt to kilos, and you can see here the size of different kind of resistors that can we see in our instrument or equipment or in any device. Now, what about variable resistors, which is another kind of electrical resistors, and sometimes call it potentiometers instead of variable resistors. This variable resistors has three terminals, okay, with sliding or rotating contact that forms an adjustable voltage divider. As we see in this kind of variable resistors, you have three terminals like this also. This is three terminals. This is sliding arm to make variation in the value of resistor here, and this is another kind of rotating. This is rotating, this is rotating, this is rotating by screw, you see here, screwdriver. This is also a rotating arm, okay. This is sliding, and this is a rotating, okay, to form adjustable voltage divider. If only two terminals are used, one end and the wiper, it acts as a variable resistor, as will be in this symbol of variable resistor. We have three terminals. The resistance between pin 1 and pin 2 is fixed, and the variable resistance coming during pin number 3 according to number 1 or to number 2. So if this arm is go in this direction, so the resistance between 1 and 3 is increasing, and the resistance between pin 3 or terminal 3 and terminal 2 decreases, okay. This is another symbol of potentiometer. So Their values can be varied manually, okay, by this arm or by this arm, okay, according to the requirement. Okay, so this is simple of variable resistors. Now about resistance units. Resistance is measured in units called ohm. Measurements of resistance can be kilo ohm and mega ohm as shown in the following table. As you see here, this is different resistance units. As you see here, the meaning and the written value 150 ohm we can written as 150 R0, 100 kilo or 100,000 ohm, 100 kilo, 2 mega, or we can written it 6 is 6 zeros, 2 millions ohm, 2 m, 2 mega, 2.2 ohm, 2 R2 means 2.2 ohm, 2 kilo ohm. So we multiply this by 1000, so it's 2200 ohm, or can write it as 2 kilo, 2.2 kilo ohm, or 2K2 means 2.3 kilo ohm. 2 mega ohm, this one can multiply by 1 million, 6 zeros here, so this one 2 million, 2000, 2 millions, 200,000 ohm, or 2M2 means 2.2 mega ohm. Now, what are the resistor color code? Resistor color code, this is one of the resistors like this. We have here 4 colors, this one, this one, this one, and this one. The first one, we call it the first digit. How to read it? So this is the first digit. This first digit may be from 0 to 9. This is the second digit, also from 0 to 9. We here have the third band or third color, which is the number of zeros after these two digits, or the multiplier. So these colors means this 1 multiplied by 1, multiplied by 10, multiplied by 100, 1000, and so on. Okay. So this is for multiplier. I mean also there is number of zeros. For example, this color means 4 zeros. This green color means 5 zeros. If this color is gold, it means multiply by zero point 0.1. The silver multiply by 0.001. The fourth color is the tolerance. So there is a tolerance in this value of resistance, maybe 1%, 2% if these two colors, maybe 5% if it is gold, or 10% if it is silver. So this is the color codes. So if it is black, okay, means 0. Here, if it is 1, means brown. If it is 2, means red. If it is 3, means orange. If it is 4, means yellow. 5, green. 6, blue. 7, violet. 8 is gray. 9 means white. And if it is brown, so the tolerance 1 plus 1 minus 1%. as you see here, this color tolerance. It is red, plus minus 2%. It is gold, 5% tolerance. It is silver, 10%. So let's see an example. This is a resistor. How to read the color code of this resistor by these four colors. Okay, so this resistor has color bands of yellow, violet, red, and gold. So yellow means 4, violet means 7, red means the multiplier by 2. So the value is 4, 7, and 2 means 2 zeros. So this multiplied by or 10 to by 100. Okay, so the value is 4, 7 multiplied by 100. So the value is 4500 ohms, and this is gold, means the tolerance is plus minus 5. Okay, as tolerance. So the value 4500 ohm or 4.5 kilo ohm. Now continue with the electrical resistors. Okay, there is a series circuit with the resistors. So what's the meaning of series circuit? Series circuit is that there is only one path for the electrons to flow from the negative part passing resistors to the positive part of the battery, as we will see in this picture. For the series circuit, this is a series circuit with three resistors. Resistor 1, 2.5 kilo ohm. This is resistor number 2, 1 kilo ohm. This is resistor number 3, 3 kilo ohms. Okay, these chain, okay, with the three resistors connected to the negative part. This is the negative part of the battery or power supply, and this is the positive part, this one. So the current or electrons from to the negative goes from the negative part through the three resistors in one path until to reach the positive terminal of the battery. Okay, so this is three resistors, okay, connected in long chain from one terminal of the battery. You see, from this one terminal to the others. Okay, and this is called a series circuit. Now, what are the characteristics of series resistors? This is series resistors. This circuit with three resistors R1, R2, R3, 2.5 kilo ohm, 1 kilo ohm, 3 kilo ohm with battery source. So we have here flow of electrons, flow of current from the negative to these resistors to the positive, or from the positive to the negative. Okay, so the total resistance in this circuit equal to the sum of this resistance or this resistor with this one, R1 plus R2 plus R3. Okay, and the current in this circuit, okay, will pass through each resistance with the same value. The current these resistors will be in the same value. Okay, and the equivalent of these resistors is approximately equal to the large resistance in this circuit. For example, if this is 1 mega ohm, this is 10 kilos, this is 2.5 kilos. So the equivalent of this circuit is equal nearly to the biggest one, for example, with 1 mega ohm of this. Okay, the resistors of this circuit will have in each resistors have each value of voltage. So the voltage here will divide it through this one, and this one. So all of the ends of these resistors has each value of voltage. Okay, that will be discussed next slides. As we said also, these three resistors, or maybe more three resistors, can be replaced with a single equivalent resistance R equivalent. So as we said in this series circuit, the R equivalent is equal to the sum of all of these resistances. Total voltage is equal to the sum voltage across each resistors in the circuit. As we said here, the value of this, the voltage of this battery is equal to the voltage in this resistors and this one, this one. So V of battery equal V of R1, V of R2, V of R3. For example, by connecting three resistors in series, this one R1, R2, R3, okay, connected to the source of for battery or voltage source, the total resistance in the circuit is equal to the sum of individual resistances, since the current from this power supply, okay, or from this voltage source, okay, has to pass through each resistor in the circuit. So this current, this is the circuit, three resistors in series. This is equivalent resistances, has the same current. Okay, so this current has to pass through each resistor. So this current will pass through R1, R2, R3. So in this circuit, the resistors of this circuit will have multiple voltage. So we have here V1, V2, V3, and V1 equal this current multiplied by R1. V2 equal, we see that it is the same current in this circuit, series circuit. So V2 equal the R2 by the same current. R3 also I multiply by R3. This is according to Ohm's law, also that will be discussed next slides about Ohm's law. So the voltage in each resistance is a multiplication of the current by the resistance. So the equivalent of this series circuit is like this, okay? So this is the R equivalent, which is equal the to the R1 plus R2 plus R3. So the voltage here is equal the voltage here, and the voltage here of the R equivalent is equal V1, V2, V3, which is equal the voltage of this power supply or of this source. So R equivalent equal R1 plus R2 plus R3, and V across this resistance equal R equivalent multiplied by this current, and I current I equal V divided by R equivalent according to Ohm's law. Now let's take an example of series resistors. The circuit below includes three series resistors, each one 100 ohm, 100 ohm, 100 ohm, 100 ohm, as you see here. Okay, 100 ohms. This one, and this one. Okay, this is a series resistors. Okay, equivalent to one resistor. Okay, this is the equivalent of this resistor, 300 ohms. From where we get this one? From 100 plus 100 plus 100. Resistor 1, 2, 3 equal 100, 100, 100 equal 300 ohms. So the R equivalent, okay, now is 300 ohms. Okay, the result of the equivalent resistance here by adding resistor 1, resistor 2, and resistor 3. So that we have here the R equivalent for this series circuit or series. Now let's see what about parallel circuit with resistors. In the last slide we talked about series circuit with resistors. In the parallel resistor there will be many paths from head to head and tail to tail. As we see here in this parallel resistor, we have here R1, R2, R3. They are three resistors in parallel. These parallel resistors used as a current divider. You see here the current I total is divided to I1, I2, I3. Okay, and these three currents are summing in this point here, this node, and goes back again to the same source. So the parallel resistors used as a current divider. So IT equal I1, I2, I3. While in series resistor, there is a voltage divider. The voltage here, okay, divided into V1, V2, V3 in series circuit. But here we have the same voltage, 12 volt, the same across this R1, across R2, across R3. So the voltage the same. We have here multiple or many paths for the current. So it's here a current divider, okay, but in series circuit we have a voltage divider. So the equivalent of this parallel resistors, okay, we can see this is the R equivalent, okay, 1 over I equivalent for these resistors, 1 divided by R1, 1 divided by R2, etc. Okay, so this is the parallel circuit, and this is how to get the equivalent resistor for these three resistors. Now, how to calculate two parallel resistors? If any two equal resistance in parallel has the equivalent resistance, total value is multiple the values divided by the sum. This is the formula. So if we have here two resistors, R1, R2 in the circuit, so the R total, or the equivalent of the two resistors in parallel, is multiple the two values divided by the sum. Let's see example here. We have here two equal resistance, two equal resistance, two equal resistance. The equivalent of this is this one and this one, this one. So this is the formula, 4 by 4. See, 4 by 4 divided the sum is equal 2. 4 by 4 divided by 8. 16 divided by 8, this is 2. What about this one? 6 multiplied by 6 divided the sum is equal 3. 12 by 12 divided by the sum 40 is equal 6. So this is the equivalent resistance of two equal resistance in a parallel circuit. Now let's take a question or a problem about parallel circuit with resistors. You can do it as a homework. Okay. The question is, if there is a circuit consisting of three resistors connected in parallel as this figure, we have here three resistors in parallel, R1, R2, R3. This is 100 ohm, 100 ohm, 100 ohm. And these resistors in parallel, okay. So if we have each resistance has the same voltage in this circuit, so the question is calculate the equivalent resistance or equivalent of the circuit. What is the equivalent circuit for these three resistors? If we have a power source here between this point and this point across all of these resistors, if there's a 12 volt is applied here, calculate the potential drop voltage across each resistor. So if you have here a 12 volt in parallel circuit with the three resistors, what is the potential for each resistor here? Okay. Now, what about if we have a circuit with parallel and series resistors, as we see in this figure? We have here circuit, this resistor R1, we have here resistor R4, 6 ohm, 2 ohms, these in series, and R2, R3 in parallel, 4 ohm, 4 ohm. So this is two equivalent, the same with the same value. We have here a source of 12 volt. So if we want to have another equivalent circuit for this, we can see this circuit. Still there is R1, still there are 4. But what's the equivalent for two equivalent with the same value of resistors? We have here 4 by 4 divided by the sum, which is 8. So we have here equivalent 2 ohms. So we have here series circuit instead of this circuit with series and parallel. Okay, so we have here R1 2 ohms, 2 ohms, 6 ohms. So how to find the equivalent resistors in parallel and series circuit like this one? So the equivalent resistance for these three is 2 plus 2 plus 6, which is 10 ohms. So we have here R equivalent for this R2 and R3, multiply R2 by R3 divided by the sum. We have here 2 ohms, you see, 2 ohms. So R total, we have here 10 ohms for R1, R equivalent, and R4. This is actual example. You can see this in automotive vehicles. Okay, we have here, this is two loads, two bulbs in series. We have here two motors in parallel. So this is bulbs. This is series. We have here switch. We have two parallel motors in parallel. So you see here this switch, it is closed. Okay, the motors are is okay, and with the pulse. Okay, so this figure shows actual photo of series and parallel circuit, consists of two loads in series and two load motor as fans. Now this is the reference for this topic number 2. You can follow, you can read, you can visit these links to get more information about this topic of components, which is the active and passive components. Thank you for your attention, and also thank you, and any questions I am ready to answer.